first presenter is Masami Hayashi. Please present. Oh, let's start. Okay.
Thank you very much. My name is Masami Hayashi. I'm from Clean Planet. So I'm going to present about our company, who we are, what we do, and then what we are thinking for the future. So development of quantum hydrogen energy and its practical applications. So first, who we are. Our vision is to realize a world where everyone on Earth can thrive and live a healthy and happy life to their full potential. And our mission is to create safe, stable, and affordable clean energy and make it available to all humankind to protect our beautiful planet Earth. Very big vision and mission. And precisely, we are making this new energy to bring energy revolution to the world. We founded in September 2012, and our shareholders are Mitsubishi Estate, Miura, who is the top share industrial boiler company in Japan, Mitsubishi Corporation, and a major power company. And this is our founder and CEO, Hideki Yoshino. He founded Clean Planet soon after the Fukushima nuclear disaster in 2011, feeling the need for new, safe, clean energy for the world. And why he started? So as you may recall, in this precise region, Tohoku region is called, a huge earthquake happened on the 11th of March in 2011. And there was this nuclear disaster in Fukushima, a little bit south to here. So this was really devastating for all of us in Japan. And so Hideki visited right after the earthquake, all the areas, and then really felt the need for new clean energy for this country and then also for the world. And as we are experiencing climate crisis every year, and then it feels like it's worse every year. So it was really surprising to see like a 49.6 degrees in Canada. That was back in 2021. But here in Japan also, in Tohoku region, for example, this is a cool weather here in Tohoku. But I have heard that it's now more than 30 degrees every year in summer, which never happened a few years ago. Well, this was in Australia, as you may recall. So we want to stop this from happening. And then how we are doing it. So everybody knows in this floor that, well, we were inspired by this presentation back in 1989 by Fleischmann Pons, Professor Fleischmann and Pons. And Professor Iwamura and Professor Ito were with us at Tohoku University for 10 years, from 2015 to March this year. And then they established the methodology of heat generation for us. Bringing their methodologies to, we have a laboratory in Kawasaki, just 30 minutes from Tokyo. And we are now doing R&D for practical application. We have a very nice team there, and we're discussing literally every day how to make this happen. And this is a glance of what we are developing that I'm going to talk a little bit more in detail. So, what we do more in detail. First, the methodology. We call it quantum hydrogen energy, or QHE. So this is a heat generating method using nickel and copper nanolayers and hydrogen that I think everybody knows that Professor Yomura is going to talk about more in this afternoon. So what we do is to have these nanolayers of copper and nickel on top of nickel base. We make hydrogen, make diffusing inside a nanosheet, metal sheet. The summary of the advantages of QHE is that this is high energy, CO2-free, safe, stable, and low cost. And low cost especially because we don't use palladium. We use just nickel and copper, and also light hydrogen. We don't use deuterium. So it's very low cost. And we have one experiment that we did in our laboratory in Kawasaki that it lasted for, the heat generation lasted for 589 days, just on the first day to introduce hydrogen. And then we didn't add hydrogen afterwards, and it lasted 589 days. And this is what we are building right now, QHE heat module. And this is scalable and connectable. It's a tube chamber, tube form chamber, which has a 10 centimeters diameter, and the height is 120 centimeters. So it's like this big. And well, the weight is normal 12 kilograms. We don't use anything special. It's just a stainless metal. We make this heat module very compact and lightweight. It requires no structure, special structure to block high heat or radiation. And it can be installed anywhere. This can be connected in series or parallel to meet different temperature and volume needs. The heat medium can be water for boilers, or it can be air for dryers. Yeah. Using these heat modules, the image of future society that we are visioning is something like this. So this is the QHE power distributed grids for electricity and heat cogeneration system. So we are currently with Miura, we are building QHE powered industrial boilers. So following that, we will advance to megawatt scale distributed power generation and cogeneration systems. This QHE can be potentially to go beyond an alternative energy, and it can bring a future with decentralized energy supply. A fully distributed power generation is possible. Energy supply is available, can be available anywhere. And the further potential is as a power source for mobility, cars, ships, even for space exploration. Our patent portfolio, we are very proud that we have 113 patents granted all over the world in 23 countries. And then we have filed 270 patents. And then we are continuously adding 2 or 3 patents every month, granted per month. And our roadmap. So, so far we have come from concept to prototype. So the first phase was with the Hokkaido University, Professor Iwamura and Ito participated first in an EDO project, as Professor Iwamura said, explained yesterday, from 2015 to 2017. And there we have established the heating methodology. And afterwards, we brought that methodology to Kawasaki in phase 2. So we established the laboratory for application development. And in phase 3, we are currently developing this heat module to make a QHE powered industrial boiler. And from afterwards, we will bring scaling QHE for real world impact to prepare. We are now starting to prepare for mass production in collaboration with partners. So in phase 4, we will be building pilot plant where we will develop the mass production methodologies, and we will partner with major companies to start mass production and then bring, start sales basically. One big news is that we have been granted 7 million US dollars, 1 billion Japanese yen from the Tokyo Metropolitan Government just last month. So we started a new project from April 1st of April to build precisely this pilot plant in preparation for mass production. So the future with this CO2-free quantum hydrogen energy is getting closer and closer. We are building heat source for industrial heat, especially boilers first. And boilers can be used to heat and also for air conditioning this city. That's why we are partnering with Mitsubishi Estate. And of course, it can be used for the air conditioner or the heat electricity needs for AI data centers with something like this, cogeneration system. And it can be, of course, used for greenhouse, can be used in remote areas, islands, mountains, and in the future for bigger power generation systems as well. And for the future, in the future, also for space exploration. With this new energy, QHE, we hope to bring a new future to the world. Thank you very much.
Thank you very much. Any questions?
So, for your actual target 25 kilowatts output power, what will be the normal operating temperature?
The temperature, the heat generation starts, it occurs between 700 and 900 degrees, as Professor
How much?
Yomura.
700?
to 900 degrees Celsius. Yeah,
Okay.
this is the same methodology that Professor Yomura uses.
Okay. Did you make any calculations regarding the cost of the energy? And what kind of energy it will be? Thermal energy? Or it will be converted into electrical energy somehow?
Yes, okay, yeah. Well, it produces heat. So, the heat will meet the heat demand. So, for example, boilers, we will use it as heat. And afterwards, using the boilers, we can do the power generation.
I didn't understand. Did you make calculations regarding the cost of the energy in terms, let's say, of the fuel? Because the fuel will be, in your case, apparently hydrogen.
Yes.
Did you make any calculations how will be the cost of the fuel? Well, let's say.
Yes, it's going to be.
1 kilowatt.
Yeah, it's going to be very cheap. Like we are calculating that it's going to be like 1/6 of natural gas.
Okay, thank you.
Next question.
Yes,
Yes.
Rob Kimball with Solidic Labs. You showed a spec sheet for your Icarus 24. Does that have a rated power? Watts?
What? Yes, it's going to be 24 kilowatts.
24 kilowatts?
Yes. Yeah, the Icarus 24 model is for 24
That's the
kilowatts.
output. What is the input to get the 24 kilowatts?
Okay, yeah. The input, we are, the COP-wise, we are aiming more than 5 and hopefully get to 10. That's our goal.
Okay, thank you.
Yes.
Very impressive.
Thank you.
Please.
Yes.
Hello. So, just fast questions. So, is the prototype already running, or are you still working on it?
Yes, we would say the pre-prototype is already completed. So we have confirmed that the module that I just presented is working, and then we are now scaling up to reach the 24.
Can it be seen? Is it open to the public, or is it closed in a lab? Okay. And are you open to other external investors in this venture?
Yes, yes.
You are?
Currently,
Okay.
we'd like to, we are fundraising currently. Yes.
So you're open to any kind of participation also
Yes,
from?
well, not any kind, of course, but we are very careful actually in the partnering.
Okay.
Yeah, but we are open, yes. Thank you.
Thank you very much.
Thank you.
Any questions? So thank you very much your presentation.
Thank you very much.